QOD 423, a cautionary tale about timers and acorns. McGeester was hiking in Mark Twain National Forest and found a beautiful gnarled oak tree with a squirrel's winter nest near the top. From the nest, the squirrel dropped uneaten acorn bits to the ground below. With only his trusty timer, McGeester measured the fall of acorn bits in seconds. With only the times and the known acceleration of gravity, McGeester wondered, how high is that nest? And then he got to work. Okay, so we have a range of times in seconds, but we have a range. We don't have a single answer. We know gravity, 9.81 meters per second squared. We might know some other things, but those two for now seem to pop up. So we have an oak tree with a squirrel's nest in it, and it's dropping, the squirrel is dropping acorns to the ground. We know times, we know gravity, we want to know height or distance, means the same thing. Well, if all we have is time, let's look at our formulas. This one, distance, or in this case height, equals initial velocity times time plus 1/2 a acceleration, which is gravity, t squared. We know acceleration, we know t squared. If the squirrel's dropping the acorns, what's initial velocity? Well, it's 0. So we can just ignore that. And that leaves us with distance equals 1/2 a t squared. So let's take a look at our times and see if we can find a value. I copied the times from the problem over to this spreadsheet. I could punch them in the calculator and divide by 5, or I could let the technology work for me. Spreadsheets are wonderful tools. So, equals average, A-V-E-R-A-G-E, and it automatically selects the closest column. In this case, B2 to B6, that's where our data is, and hit enter. It rewrites the formula in the proper language, and if I hit enter a second time, it gives us an answer, 2.2576. And that's going to be seconds. So let's take that and use it in our formula. 2.2576. So we have time average 2.2576 seconds. Now, even though we only had 3 digits in our measurements, I'm going to go ahead and leave the 4th digit from our calculation. That way we don't get a rounding error later. So let's rewrite the formula. Distance equals 1/2 acceleration, 9.81 meters per second squared, times, let's put some parentheses just to make things easy to read, 2.2576 seconds squared. And let's do some unit analysis. We're going to have meters per second squared times seconds or seconds squared. And that means that the seconds squared are going to cancel each other out, leaving us with an answer in meters. Now, is an answer in meters what we want? We're trying to find distance. That should make sense. All right, so let's go to our handy-dandy cheetalator and see what happens. 0.5 times 9.81 times 2.2576 squared. Make sure you get that square in there. If you don't have a squared button, just times 2.2576 again. And I get an answer. Wow, that's an ugly number. 24.99959,681. Well, this is where our significant digits comes in. What's our lowest number? Well, our times had 3 digits. but our acceleration of gravity only has 2, and this 9 definitely tells us to round up, so we come up with an answer of 25.00 meters. And that should be the height of the squirrel's nest who's dropping acorns. Guys, have a wonderful day. Beware of the storms. We have a lot of rain coming in. If you get any sunshine, go take advantage of it. If not, hunker down and watch the rain from a nice window. Have a great day, and I will see you later.